Example 3 asks us to solve the right triangle and give lengths to the nearest tenth. Now solve the right triangle. That just means you're going to find the lengths of all the sides and the measures of all the angles. So let's start with angles, because in this case that'll be easier. So angle B. Well, all the angles of a triangle always add up to 180 degrees. So we know this one's 56 degrees, this one's 90 degrees, so we can just subtract those from 180 to find the third angle. So 180 degrees minus 90 degrees minus 56 degrees is going to give us angle B. So 180 minus 90, that's 90. 90 minus 56, that's just 34. So this one here is 34 degrees. When you're dealing with right triangles, you could actually just say 90 minus 56 is 34 because there's always going to be 90 degrees left over to split between these two angles. But let's get used to subtracting from 180 because as you go on in trig or even solve other triangles, you won't necessarily have a 90-degree angle. So then let's solve for A. Well, let's first figure out what different things we have here. Here's our right angle, so the side opposite the right angle is our hypotenuse, and then we have the two legs. So now we have to decide which angle we want to work with. We can work with either. I'm going to pick angle A. So in relation to angle A, this is my opposite. So if I look at SOHCAHTOA, I have the hypotenuse. I'm looking for the opposite. Opposite and hypotenuse, that's sine. So I know that the sine of an angle is equal to the opposite over the hypotenuse. My angle, I'm using this angle, so it's 56 degrees. The opposite is A, and the hypotenuse is 8.7. Now if I use my little triangle, so I am looking for the opposite, so I'm multiplying the hypotenuse by the sine of the angle. Also I can see here, I'm dividing by 8.7, so I've got to get rid of it by multiplying by 8.7. So 8.7 times the sine of 56 degrees, and that will give me 8.7 times the sine of 56 is equal to 7.21. We want to go to the nearest tenth, 7.2. I look at the next number is 1. That means leave it at 7.2. My units are centimeters. So that's my answer for A. This is B. Angle B. And now I want to find little b, my last side. Again, I can choose to work with either angle. I'm going to stick with this one, 56. So if that's the opposite, that's the hypotenuse. This is the adjacent. I like to stick with the same angle within a triangle if I can. You can't always, but I like to if I can, just because that way I can keep my labeling the same and I don't have to change anything. So now I do have the opposite, but this is an estimate, right? We rounded off to get that. So let's use this 8.7 because we know that this one is actually 8.7. So I'm looking for the adjacent. I have the hypotenuse. Now I'm going to use so cosine. So we know that the cosine of an angle is equal to the adjacent over the hypotenuse. So my triangle looks like this. Cosine is adjacent over hypotenuse. I am looking for the adjacent, so I can cover up the adjacent. It's going to be another multiplying question. So cosine of 56 degrees is equal to the adjacent, B, over the hypotenuse, which is 8.7. So B is equal to 8.7 times the cosine of 56 degrees. So 8.7 times the cosine of 56 degrees. That's equal to 4.86. 4.8, the 6 tells me I need to round up, so that's 4.9. Again, my units are centimeters. And that's my answer for B. Always do a quick check. Your hypotenuse should be the longest side, and yes, it is. These two are shorter, so that's a good sign that we did stuff right. And there's your answer. So now we know that A is 7.2 centimeters. B is 4.9 centimeters. And we know all the angles, so we have solved this